So to start off, let's look at this. It says if the power of cosine is odd, save a factor of cosine x squared and use cosine squared x equals 1 minus sine squared x to express the remaining factors in terms of sine. Then substitute u equals to sine x. So if you already know cosine squared x is equal to 1 minus sine squared x. So when we have a problem when cosine has an odd exponent and we are trying to integrate it, we are going to use this method to integrate it because you're going to need that in calculus. So let me give you an example. So here we have the integral and we have cosine exponent as an odd number. So what we're going to do is we're going to leave the sign alone, but we're going to take out a cosine so that we have cosine squared x. Because when you think about it, cosine squared x times cosine x is equal to cosine to the power of 3x. So take one out, and we know that cosine squared x is equal to 1 minus sine squared x. So we can use this for this. And I will show you how to do that. So cosine squared x can leave the sine x alone. Cosine squared x is 1 minus sine squared x. Here we have cosine x and sine x. Sine to the power of 6x. And when we have the exponent of cosine is odd, we can use u for sine. So u would be equal to sine. So in this example, we would put u as sine, but u would have an exponent of 6. Put u as a sine, and we have another sign right here. So this can also be u. So this is u squared since it's sine squared. And leave the cosine x here. Also, when we derive u sine x or sine x, the derivative of sine x is cosine x dx. And we can automatically put du into this. So this will be much more simpler. So u to the power 6 minus or times 1 minus u squared du. And we can just forget about the du at this point. So distribute the value. U to the power 6 times 1 is u to the power 6. U to the power 6 times negative u squared is u8. And now we can integrate this. This would be u to the power 7 over 7 minus u to the power of 9 over 9. And once we're done, we could just plug back what we got for u. So in this situation, we can plug u in for sine, or sine for u. So this would be sine to the power 7x over 7 minus sine over 9 plus c. And this is our final answer for this question. So here is what would happen if secant is even. So if the power of secant is even, save a factor of secant squared x and use secant squared x equals to 1 plus tan x to express the remaining factors in terms of tan x. Then substitute u equals to tan x. So let me give you an example of what to do in this situation. So here we have the integral of 6 secant to the power of 4x dx. So we can have a secant squared x here. We can take 2 out. Secant squared x here. Secant to the power of 2x is equals to tan squared x plus 1. So we can plug that in. Also, we have to leave this alone. We don't have to do anything right now. Just know that if you have two values of the same, just like do one, just leave one behind because it'll be much more simpler if you do that. So plug in u equals to tan. Squared plus 1. When we derive the u, we will get secant squared x. And this is our du, so we just have du over here. So what we have to integrate is 6u squared plus 1. And we can distribute the 6. So it will be 6u squared plus 6. Now we can integrate it. So this is simple integration. 6 divided by 3 is 2. So this would be 2u to the power of 3 plus 6u. And plug in our u, which was tan. So this would be 2 tan to the power of 3x plus 6 tan x plus c. Now, if the power of tangent is odd, save a factor of secant x tan x and use tan squared x equals to secant squared x minus 1 to express the remaining factors in terms of secant x. Then substitute u equals to secant x. And I'll show you an example. So in this example, we have tan to the power of 5 and secant to the power of 4. So we have to leave secant x tan x. So immediately we can take out 1 tan x from tan to the power of 5. So tan x, this would be tan to the power of 4x. And we could take out 1 secant from secant to the power of 4. So this would be secant to the power of 3x. So we have our secant x tan x over here, and we have tan to the power of 4x times secant to the power of 3x. But we can simplify this further to make it more simpler. So tan to the power of 4 can be tan to the power of 2x. So we got 2 of these. And we have to leave this right here. We will have to substitute u in for secant. So whenever there's a u, just plug in secant. And the derivative of u or secant is secant x tan x. And we have secant x tan x right here. So this would be the du tan squared x is equal to secant squared x minus 1. So this would be u2 minus 1. And then another one because we have another tan squared x. one, we still have to plug in u for secant. So this would be u to the power of 3. So this is what we have so far, and now it's time to simplify this further by distributing it. We can distribute the u to the power of 3 to this whole function. This would be u8 to the power of 8 over 8 minus u to the power of 5 plus 1 is u to the power of 6 over 6 plus u to the power of 4 over 4. Now remember we have our u is equal to secant x, so plug it back in. Secant to power of 8x over 8 minus 2 divided by 6 can be 1 over 3, so it'll be 1 over 3. And plug in secant x for u, so it'll be secant to the power of 6x plus 1 over 4 secant to the power of 4x.